Hello everyone. Today I am going to represent an important concept in machine learning called logistic regression. Logistic regression is a widely used supervised learning algorithm that is mainly used for classification problems. Unlike linear regression, which predicts continuous values, logistic regression predicts categorical outcomes, usually in the form of probabilities between 0 and 1. In this presentation, we will understand the introduction to logistic regression, what logistic regression is, how it works, the role of the sigmoid function, the properties of the sigmoid function, applications of logistic regression, and conclusion. Introduction to logistic regression. Before understanding logistic regression, let us briefly look at supervised learning. In supervised learning, the machine learning model is trained using labeled data. This means that for every input, we already know the correct output. The goal of supervised learning is to predict the output when new input data is given. The output can be of two types. One is numerical values, such as predicting housing prices. Next one, categorical values, such as predicting whether an email is spam or not. Logistic regressions mainly output is categorical, especially binary classification problems we use logistic. What is logistic regression? Logistic regression is commonly used for classification tasks. For example, predicting whether a student passes or fails, or detecting whether an email is spam or not, predicting whether the patient has a disease or not. In such cases, the output is not a number, but a category or class label. So, logistic regression helps us calculate the probability that a given input belongs to a particular category. The basic idea of logistic regression is to first compute a linear combinations of input features. This is similar to linear regression, where we calculate z equal to mx plus b. However, instead of using this value directly as output, logistic regression passes this value through a sigmoid function to convert that continuous values into probability, either 0 or 1. Linear regression. It predicts the continuous values. Example, predicting temperature or salary. In case of logistic regression, it predicts the probability and class labels. Example, yes or no, true or false, and 0 or 1. To convert the outputs into probabilities, the logistic regression uses a special mathematical function called sigmoid. It uses the S-curves. The values falls between 0 and 1. Here in linear regression, we use the best fit line. In case of logistic, we use the S-curve. Here we use sigmoid mathematical function. So the idea behind the logistic regression is the linear combinations of input features and the sigmoid function to convert it into probability. Types of logistic regression. There are three types: binomial, multinomial, ordinal. In case of binomial, we classify the two classes, either 0 or 1. In case of multinomial, There are more than two unordered classes, for example, cat, dog, seed, etc. But in case of ordinal, more than two ordered classes, for example, low, medium, high. Now let us understand how logistic regression works. First, the model calculates the linear equation using the input variables. These equations produce a continuous value which may range from negative infinity to positive infinity. To achieve this, logistic repression uses a sigmoid function which converts the continuous output into probability value between 0 and 1. If the probability is 0.5, that represents class 1. Less than 0.5, that represents class 0. So this is how the logistic regression converts a numerical output into categorical prediction. Mathematical representation. In logistic regression, the input data is usually represented in the form of feature matrix. Each row represents an observation and each column represents a feature. The model calculates a weighted sum of these features and then applies the sigmoid function to obtain the final probability. The probability value tells us how likely the input belongs to a particular class. So sigmoid is a mathematical function that maps any real value number into a value between 0 and 1. If statistic X saved, so make it probable, particularly useful in scenarios where we need to convert the output into probabilities. So this function is also called as logistic function. So the sigmoid function is the key component of logistic regression. The sigmoid function is a mathematical function that converts any real value into value between 0 and 1. So this curve is also called as S-shaped curve, also known as logistic curve. So this curve is useful because it allows us to interpret the output as a probabilistic value. For example, any values close to 1 indicates high probability. Any values close to 0, this indicates low probability. The formula of the sigmoid function is sigma of x, which is equal to 1 by 1 plus e to the power of x, which is also equivalent to e power x divided by e power x plus 1. Properties of the sigmoid function. The sigmoid function has several important properties that make it useful in machine learning. First is the domain. The input to the sigmoid function can be any real number from negative infinity to positive infinity. Second one is asymptotes. When the input becomes very large, the output approaches 1. When the input becomes very small, the output approaches 0. However, it never actually reaches 0 or 1, but it only gets very close to. Third one is monotonicity. The sigmoid function is monotonically increasing, meaning the output increases as the input increases. This is called monotonicity. Finally, differentiability. The sigmoid function is differentiable. It is very important because machine learning algorithms use gradients to update model parameters during training. These are the properties of sigmoid function. Next one, the applications of logistic regression. Logistic regression is widely used in many real-world applications. Some common applications include medical diagnosis. Here, we are predicting whether a patient has a disease or not. Another one, spam detection. Here, we are identifying the mails which are spam, which are not spam. The next one, credit risk analysis. Here, we are predicting whether the customer will default on a loan or not. The last one, the customer churn predictions. Here we are predicting customer will leave a service or not. So like this, logistic regression, which is used to solve the classification problems. Because of its simplicity and efficiency, logistic regression remains one of the most widely used classification algorithm. So this is the one of the applications. Here we are predicting whether the day is sunny or rainy day. So based on the temperature features, we can classify, we can predict the outcome whether the day is sunny day or rainy day. Here we can set the classification threshold, that is 0.5. The values are less than 0.5, we can have one class. If that values are greater than 0.5, we can classify the another class. So we can have either 0 or 1. So 1 means greater than 0.5, 0 means less than 0.5. So if you track the values for classifying value of the input and also here the threshold value is suppose 0.5, the temperature's value is like 0.5, it's below 0.5, like not exactly 5, it's like below means we can predict the day is rainy day. Suppose if the value is, in this slide, if the value is greater than 0.5, means here the value is greater than 0.5 means this is the target value. If it is above this target, we can predict sunny. If below the target, if this predict rainy day. Next, conclusion. To conclude, logistic regression is a powerful and widely used classification algorithm in machine learning. In this presentation, we discussed the concept of supervised learning, working principle of logistic regression, the importance of sigmoid function, and the properties that make sigmoid function is suitable for classification. Although it is a simple algorithm, logistic regression forms the foundation for many advanced machine learning models. Hope you understand about logistic regression. Thank you for your attention.